Good morning. Welcome to the lecture series of blockchain technology. This is Naveenraj from Assistant Professor, Department of CSE IoT. In today's topic, we are going to discuss about blockchain security architecture. Mainly, it is focused on core principles. So, normally, we all know that blockchain technology is a decentralized technology, so there is no central authority. We are going to divide this secure architecture into different principles. So normally blockchain systems are designed to be secure by its architecture, but that security is not an automatic. It is the result of carefully applied core principles that guide how much blockchain protocols, smart contract networks, and applications are built and maintained. So there are various fundamental principles that make up the secure blockchain architecture. So first one is decentralization. So normally in blockchain technology, decentralization ensures that it's a control over the network that is distributed across multiple participants. Here the multiple participants are nothing but whoever the connected in the blockchain network, we call as multiple participants. So it will reduce the reliance on single point of control. So normally in security principle, reduces single point of failure and re-assist censorship and tampering. So normally in decentralization there is no central authority. So here single point of failure contact is failure. So it increases fault tolerance. Nobody is going to monitor you. So what happens here? It will increase the fault tolerance. For example, the Bitcoin and Ethereum achieves security through thousands of nodes, validating and storing the blockchain. So here the network people who are connected in the network will be also responsible for validating and storing the blockchain. Next is immutability. The second principle is immutability. Here once data is recorded on the blockchain or confirmed, it cannot be altered or deleted. This is the one of the major principles or features of the blockchain technology. Here there are various benefits of security, we call as protects data integrity. So normally it prevents unauthorized tampering and also it supports forensic traceability. Now this immutability can be implemented in the secure architecture based on the cryptographic hash function and also the consensus validation before appending the data. So here we have a consensus mechanism, so that will append the data whenever the transaction is validated. Next, for example, here the financial records or land registration stored on blockchain are permanently tamper proof. This is the example of immutability. Next is the third principle is transparency and auditability. So auditability. So here the blockchain data is openly available normally in public chains. It allows users to independently verify transaction and system integrity. Here the various benefits of this security enables community monitoring. So here the people from different areas we can responsible for monitoring and validating the data. It also prevents hidden malicious actions and also facilitates compliance and auditing. So in order to implement this transparency and auditability security architecture, we are going to implement a smart contract on Ethereum that can be audited by anyone before interacting with them. So next principle is cryptographic security. So here we are normally during the encryption and decryption there are various cryptographic functions are available. Here the advanced cryptographic algorithms are used to secure your data, transactions and identities. The various key elements of this cryptography securities are hash functions. Here SHA 256 hash function is used in order to ensure your data integrity. Then we also use public key cryptography, which enables digital signature whenever before validating or whenever you are sending some data, so it will be verified with the digital signature. And also we have a Merkle trees. it provides efficient and secure data verification. So we have a pool of data. The verification is very difficult when the large amount of data is installed. So here we are using this Merkle tree in order to avoid, in order to trace the transaction security. So here we can ensure confidentiality, authenticity, and wrong reputation. It verifies transaction integrity, and it consensus integrity is next to principles. Here the consensus mechanism like proof of work, proof of stake, and DPoS, delegated proof of stake, practical for maintain fault tolerance. So these are the five common mechanisms we use in order for consensus integrity. Then the various security benefits here in this consensus integrities are: prevents double spending, resists malicious forks and attacks, ensures network agreement. Examples: normally in proof of stake, validators risk losing stake if they validate fraudulent. So these are the five principles of we are implementing in this security architecture. Thank you.